tangential velocity and angular velocity. Okay, so in order to understand this difference, okay, you can see on your screen right now, we have to visualize something that's called the whip. That is when ice skaters, they all are in a synchronous line and they're all moving synchronously across basically a field and a field of ice, and they are all rotating around a central point. So in order to understand this, you have to compare the last person, this over here, with this central person right here, around which the pivot is basically occurring. So this person over here that is in the center obviously does not have to work that much, but the person all the way on the outside of the skating line, as you guys can see here, has to work very, very hard. In other words, his tangential velocity must be greatest. So now let's look at the angular velocity, meaning the change in angular displacement. So in other words, how fast this angle is changing versus tangential velocity. And as you can see, it's different at each point. The tangential velocity, as we just said, at this point is going to be a lot greater than this one. And all of them, because they're in a central line, you can see that the angle between them that they've ascended is going to be the same. So angular velocity is the same in this case, but tangential velocity now is different. Okay, so how do we convert now angular velocity into tangential velocity? Very, very simply. Okay, so here's our first equation right over here. So VT stands for velocity tangential equals R, which is this radius right here, so it's the radius, times omega, and that is the angular velocity right here. And of course, as you guys know from previous videos, angular velocity is simply in rad per second. So the only thing you have to do is you have to take the angular velocity and multiply by the radius, and you convert it to tangential velocity. And if you remember correctly, tangential velocity is always going to be in meters per second. So VT is in meters per second, R is in meters, and omega, that is going to be in rad per second. So with the same exact thing, we can actually compare now angular acceleration and linear acceleration. So as you can see over here, acceleration tangential, that's a linear acceleration, and that's equal to now the radius, which is this distance right here, times alpha, and alpha, of course, is the angular acceleration in rad per second squared. So these two formulas, the only thing you have to do to convert angular into tangential is you have to multiply it simply by the radius. Because why? As we saw in our initial picture, it is the tangential velocity. It is dependent really and the distance from this central location. So once again, the angular velocity is the same, but tangential velocity changes in according with the radius. So let's go into our first problem. So in this case, we are given two different points, two different radii. So the first point is 3 meters from the central blade that is rotating. And the second point right here is 6.7 meters away from the central point of rotation. So the problem says a helicopter blade has an angular speed of 6.5 revolutions per second and an angular acceleration of 1.3 revolutions per second squared. So they're giving us the angular speed, they're giving us the angular acceleration, okay? And it says for point 1 of the blade, find the magnitude of A, tangential speed. So we have to take this angular speed, convert to tangential speed, and B, the tangential acceleration. So take the angular acceleration, which is 1.3, and convert it into tangential acceleration. So what do we basically say we do? We take these and we multiply by radius. But before we do that, we have one little problem. Let's take the angular speed first, 6.5 revolutions per second. Do you guys like that, these units? No, because what did we say? It's got to be in rad per second. So we got to take this angular speed, we got to take this angular acceleration, and we got to convert it now into this one rad per second and this rad per second squared because it's acceleration. So with that said, let us go to our trusty sketchbook, which I have open right here. And what did we basically said? We said that we were given, okay, angular velocity, and we said that it was 6.50 revolutions per second, and we said the angular acceleration, we said it was 1.30 revolutions per second squared. Okay, so as you guys can see, we just said that these are not good units, so we have to convert them. So the first thing that we have to do, if you remember correctly, to convert revolutions or degrees, we have to multiply it by the following: 2 pi rad over, we said 360. But what's 360? If you remember correctly, I told you guys I like 3 pi rad over 360 because 360 degrees, that's one complete circle, so that is one revolution. So revolutions drop out, so we are left with 2 pi rad per second, and that's what it basically, the desired units that we want for angular velocity. So 6.5 times 2 times 3.14 rad, that gives us 40.8 rad per second. Okay, so we're left with rad per second, as you guys can see right here, and these, of course, are our desired units. And we do the same thing with acceleration. Okay, so we multiply it now by, again, the same quantity, 2 pi rad, and again, it's over 360, that is correct, but it is 360 is one full circle, so it's a revolution. So once we multiply this, we see that that is going to be 8.17, and that's going to be rad per second squared. So we took the angular velocity and the angular acceleration in revolutions per second and revolutions per second squared, and we converted them into the correct units that we know. So now the problem asked us, okay, for A to find now tangential velocity. So what is the formula? The formula is R times omega. So angular velocity times the radius, that's going to give us tangential velocity. So what is the radius? We said we're going to look at the first point, and that was, the problem said 3 meters. And we're going to multiply it by omega, which is the angular velocity. So 40.8, okay, that's going to be rad per second. And once we multiply it, so that is going to be exactly 120, that's for 120, about 122, and that's going to be, we said, in meters per second. So that's meters, ladies and gentlemen, per second. And that is our tangential velocity. Now, B, they're asking us to find now tangential acceleration. Okay, and again, the same exact formula. So R times now angular acceleration. So the radius again was 3 meters, and we multiply it now by the angular acceleration, which is 8.17 rad, right over here, rad per second squared. Okay, and once we multiply these two, we see that it's going to be about 24.5, and that's going to be meters per second squared. So notice what we did. We took the angular velocity and the angular acceleration from rad per second squared, and we converted it into meters per second and meters per second squared, respectively. So at 3 meters, those are at those points, that's the tangential velocity and the tangential acceleration that it experiences. And notice how the angular acceleration and the angular velocity are the same, and they're steady at 40.8 and 8.17. So now it's very easy. So now I want you to find it for the second point, which is, I believe, 6 point, let me go back to it. 6 point, sorry, that's not it. This one right here. It was 6.7 meters. So now I want you to do exactly the same thing. So instead of 3 meters, I want you to do for 6.7 meters, and I want you to please send me the answer. Thank you so much. See you guys later. Bye.